In the book talks about relays, contactors, and magnetic starters, and overload protections. And by that we finish most of the components we will need for HVAC. You will find in the book that the following chapters talks about special components and special configuration of heating. But there's a gas. There's chapter 12 is thermostat, pressure switches, and electric control devices. That's what we'll cover next semester for the first two chapters. We'll talk about controls, sensors and controls. How do we automate the system as much as possible? And for chapter, that's 12 and 13. Then it goes to a lot of package systems, and Bill will cover that in HVAC electrical applications. But for now, we covered the major components that do work. What are those called? What the things that do work called? Loads, thank you. So we covered most of the loads. Now we want to deal with controls, and that's going to be next semester. And similarly, we'll do another paper about sensors. Sensors make our life easier and also sometimes annoying because they break a lot. So they became more reliable. So probably if you bought a car in the 90s, they had a lot of sensors that always go bad. Now you buy a car and for 10 years, nothing was wrong with it. They made the sensor more reliable. What will break the sensor? And they fixed it. The car has oxygen sensor, it has vibration sensor, it has pressure sensor. All the sensors we're going to study here, there are in your car. How does your car know the pressure in your tire is low?
Sensors.
Where's the sensor?
In the car.
Where?
Probably around in the front.
The ABS on the wheel.
No.
Is
Isn't
it
there
in
an ABS one that?
In the least place you can think of.
Is it in the
valve
front of the car?
Yes!
Where is it?
It's in the valve stem.
Oh, okay.
Because when it has a
Radio
battery,
frequency one.
it has a battery, so the battery goes back a few thousand miles, and you have to take out the tire, take out the valve, and there's a small box with a battery, and you have to change the battery. This pressure sensor sends a signal to a computer, part of computer, in your car that tells when tire is low in pressure. So again, it's beneficial, but also it's annoying because you have the process to get that out is really comprehensive. You have to take out the tire, take out the valve, take out the box, and put it in there. And that's granted that doesn't break. It breaks another issue. You have to change the entire assembly, which is expensive, around $200 for most cars for each piece of doors. And is it important? Yes, it is. Not as much as it used to. I mean, in the old days they used to have tube tires. Tube tires are very dangerous. Probably you remember tube tires, right? With
Places.
Only in bikes.
huh?
Yeah, it was like
Not in
non-train.
vehicles, only like.
They used to have them in cars in the 80s and 90s.
Really?
Tubeless came really late. Yeah,
Late?
like in the late 80s.
Yeah, well, yeah, I guess.
Yeah. So I remember we used to change take out the tire, take out the tube,
Yeah.
pass the tube, put it back, and those were really bad because if the tube get punctured, the tire will go flat. If you're in the highway, it does not sleep, it goes flat, and you have a busted tire.
Yeah.
We don't see this anymore, right? Because now we have tubeless. Even if there's a nail in it, it will leak, it will not explode. And now they also have running flat tires. Why am I talking about tires? I don't know. I just get distracted. But again, it's all related about sensors. And the more sensors you have, the more control you have over the equipment. And also it's a good way to prevent issues. Like if I have a vibration sensor, if the motor is vibrating, I have a vibration sensor in there, it can tell me that something exceeds the limit of vibration, so I will stop the motor. It will auto stop before it breaks. That's why engines do not go bad as they used to. Remember when you used to go seized and they overheat or explode or whatever? This doesn't happen anymore. Most cars have a prevention method. If it's low in oil, it will shut off the engine. If it overheats, it will shut off the engine. So those are all sensors to sense something that's going to go bad and try to prevent it. So overload, they protect the load from high ampere by draw or break a set of contacts. So there are two ways to break a circuit. Again, it's the same idea of sensors. I'm trying to break the circuit to prevent it from breaking or damaging the equipment permanently. So fuse is the simplest way to do overload protection. That's why your car has two sets of boxes, two boxes with a set of fuses in each one of them. There's one in the front, one in the back, and every small circuit in your car is controlled by a fuse. And now even mechanical part has been controlled by electronics that will shut off the mechanical part in case it goes bad. And fuse is very simple, and it works with the idea that if the load is non-inductive, means it's just a circuit for control, it can shut off the circuit if something goes wrong, it will burn because of the heat produced by the overload. So we said what's the difference between non-inductive, which is resistive, it's the same word, resistive or non-inductive, those things that do not use magnetism to operate. So the point, if the load is purely resistive, there is no coil, there is no motor, there is no need to, we cannot use fuse. Why? Because if the load gets stuck a little bit, the fuse will get burnt, and you don't want that. So fuse consists of two ends, a piece of wire. A piece of wire is made out of a mixture of alloy. What's an alloy?
Two metals.
Huh?
Two metals.
A combination of metals. It's not one. Something with mixed with other. It's kind of a mix of metals. So they protect wires, circuit components, especially in electronics, because electronics do not have any, sometimes they don't have any inductive loads, mostly resistive loads. And they just burn and you replace them. And make sure when you replace them with something with the same size, do not exceed the size for fuse. Nah, I don't want about that. So for fuse, they're really easy to detect. So you can, if it's a breaker, circuit breaker, you check the magnetic overload, you check the coil for continuity or for resistance. If it's a fuse, you also check the continuity. Some of them are clear glass, you can see through, and some of them are not. They're completely covered, so you have to go and check the continuity. Internal loads for compressor are really difficult because sometimes it's isolated and it is hermetic, so you cannot really get that out to check it. Magnetic starter, we talked about that. What is a magnetic starter? It's a contactor with overload protection. So it has an overload, meaning it has contacts that will break, and it has a coil that will draw the contact. 4 sets of contacts, they have been closed depending on the coil location. So 4 sets. And there's a magnetic coil. It closes the contact when the coil is energized. It is the heart of the system, mostly for compressors. So you will find magnetic stars on big central ACs. Once there's an overload, why would we have an overload? The motor is running too much. There's low pressure in the system. There's a leak of refrigerant, so it will overload. Once it overloads and it starts drawing too much amperage, that coil will have a magnet that will draw the other side of contact and shut off the system. So these are some types of magnetic starters. They have a bimetal relay, which is welded metals that warp and break the circuit using heat. How does that work? So if I put two metals together, and this technology is still going on for a while. So two different metals with different resistance. If I heat them, are they going to shrink and expand the same rate? No. Well, that's the purpose. So if it doesn't shrink or rub in the same rate, what will happen? It will bend. So what will happen is one of them will be shorter than the other, and I will get something this way. So they will bend, and if this is a contact here, it will cut off the circuit. They are very reliable because it's a mechanical part and the distance is very long, and it will do a snap action. Once it reaches certain temperature, it will snap and pop out of the circuit. And this is the same way as the thermal switch that you have in a motor. If the centrifugal switch does not engage, it will just pop, and this is the popping sound. This is why it cut off the circuit. Thermal relays, they use chemicals that change the resistance with heat. Again, they're both heat activated. Molten alloy, you'll find this on old boilers, which basically I'm gonna put a pin, I'm gonna use gravity, I'm going to surround that pin with molten alloy. What kind of alloy will melt really fast? Huh? Lead? Lead, mixture of lead. So we'll put some lead in it, lead with silver, whatever, and when it melts, it will drop out. That's what it looks like. So, again, those are two contacts. This is my molten alloy in the middle. It's not like if you use a wire. This will take a lot of heat, it will melt, and it will shut off the circuit. Again, if you look here, this one is gravity operated. There's a weight between the two terminals. And if you see here, it's filled with lead. Once it overheats, lead melts around like 400 degrees. It will melt and get soft, and the weight will drop down. Troubleshoot is, again, the ohmmeter is your best friend. You go and test the terminals for connectivity. Also look for molten parts. You're gonna see if anything melted or discolored or burnt. Again, we always check the contacts. If anything rattling, something is not right, that means the mechanical linkage has been displaced. Solenoid coil heater. So look at the solenoid visually and also test for continuity. Look for overloads and also for mechanical linkage. You test the magnetic starter unit completely, don't take it apart. Again, they are manufactured in certain environment, and they are put together with certain clearances between the parts, so you do not have to take it apart and put it back again. Must be treated as a unit. Whatever breaks in it, you replace the entire unit. Okay? Push buttons, we talked about those before. They are relays that when you push the button, you are engaging coil, and the coil will stay magnetized until you disengage it again. So they're not switch, it's push buttons. That's what they look like. So basically, if I push this circuit, I have engaged this relay, and it will stay connected completely until this one is pushed. So they toggle between one and the other. You push one, it gets magnetized. Until you push the other, it gets demagnetized. Question?
Isn't dash line, isn't it
Closed.
Yeah, closed.
Normally closed, so this is closed. So this now is not continuous circuit, this is open. Once I lock this in, it's gonna be continuous, it will go on. And these two are in parallel. So this will start it, this will stop. There's another one that actually does the reverse, but it's the same idea. So that to reverse the rotation for a motor, you push one button, then you push the other. And those were very common in elevators. You put the floor, you engage the circuit. Once you reach the floor, the circuit will get disengaged. So far we covered coil, contactor, contacts, just at the tip of the contactors, current overload, fuse, inductive load, thing that uses magnetism, internal compressor overload, line brake overload, where we put a fuse, magnetic overload, magnetic starter, mechanical linkage, an overload, anything that draws more amps than it's supposed to. Pilot duty overload, don't worry about that. Push button station, bunch of relays, you close the circuit, you open the other one. That's why we have single pole and double pole. What's a relay? And resistive load, which is non-inductive load, that mainly is heat or light or capacitor, resistance, and nothing but magnetic. Anything but magnetic. So facts, if the contactor failed, the whole system failed.
Yeah, because it's more, you gotta treat it as a unit, right?
Yeah, and also because if the whole logic and system of operation of the whole equipment is gone. So you have to change, the contactor is very important. The coil depends on the wire and the way it is on. So what does that mean? The coil strength as a magnet depends on how thick the wire is and how it's wanted to make that magnet. Contacts are rated by amperage, we learned that, right?
Yes.
What is the difference between a contactor and a relay? The amperage. So contacts and relay are rated based on the amperage. Contacts are made out of silver and cadmium. That's the tip of the contactor, the little two pieces that join together. And why is that? So the tips. Very good conductivity, and that's what makes them a little bit pricey. So those tips, they don't need much to connect. Once they touch, they will connect electricity. Best connectivity you can get. In some applications, they are gold plated because you don't want much connection to have them conduct electricity. How to diagnose a coil? Contacts and mechanical linkage. We did that in the lab. The simplest way to predict any circuit is a fuse. So when in doubt, put a fuse, and the fuse should be limited at the maximum allowable current in the circuit. So let's say there is no circuit breaker and you want to protect the circuit, you're going to put a fuse in the circuit. You put the fuse in series or parallel? Series. Remember the first class?
Yes.
Things in series are for safety and control. So you put a fuse in series, don't put it in parallel, it's not going to work. So in serial circuit, if it cuts out, it cuts out. Two types of overload, inductive and resistive, we talked about that. That's basically it. And finally, this schematic you already been tested on 3 times. This is single pole, single throw relay. Double pole, single throw, because they're both going to do the same thing once you energize the coil. This one is single pole, double throw. So it's the same wire. Once you energize the coil, it will do a double throw. So draw this down. This one is double pull, double throw. So it looks like it's 2 of them. And whenever you energize, it will double throw the entire system. Okay, that's chapter 11 in the book.